The second part of our equivalent ratios and ratio tables notes is to work with a ratio table. Um, don't freak out about the table. Just know that this helps you organize information, and hopefully for some of you, it'll help you see the numbers more clearly. So ratio tables are columns filled with pairs of numbers that have the same ratio. Okay, so today what you're going to end up doing is making equivalent ratios just in like a table form. So it says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 25 cups of white icing to get the same shade? So I'm given my table 6 drops of yellow for 1 cup of icing. And then I have 5 with a missing box above it because I want to figure out how many drops of yellow do I need to make 5 cups of icing. Well, what do I do to go from 1 to 5? I multiply by 5. And what I do down here, I also have to do on top. So 6 times 5 is 30. So to answer the question, it would be 30 drops. And then if you needed to explain down here what I did to solve, you could just type behind here x5 as in times 5. All right, so that one really easy, just trying to figure out what do I need to do to go from 1 to 5. The next one, so some of you maybe have heard of Joey Chestnut before. He's the guy that always wins the Nathan's hot dog eating contest. I think it's held every 4th of July. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. Well, I have a missing column before I get to my 2. So I need to think what number can go into both 12 and 2. And I know that that 2 will go into it. Or I could be like, you know what? I know that 6 I can also go from 12 down to 6 and 6 down to 2. So I'm going to divide by 6. Okay, I'm going to actually make it smaller first. So 12 divided by 6 is 2. Oh, but I don't want to find the answer right away. Okay, I got to make sure I can fill the whole thing in. So I'm going to divide by 2, which will give me 33 here and 6 here. Then I'm going to divide by 3 because I need to go from 6 down to 2. 33 divided by 3 is 11. So that's crazy. 11 hot dogs every 2 minutes. And so if I needed to explain what I did to solve, I would put divide by 2, which you would have to do \2, \3 to show that you divided both of those numbers. So when we do scaling, we're multiplying or dividing both of the related quantities by the same number. Or you could put the word 2 in here as well. Sometimes you have to scale back, which means you may have to divide first before you can scale forward to multiply. And so that's what you're going to end up doing in these next few examples. So cans of corn are on sale 10 for $4. Find the cost of 15 cans. So I can't go from 10 to 15. I need to scale back, but I need to think what number is going to go into both 10 and 4. That when I divide, I can then take this number and multiply to get to 15. So I'm going to divide by 2 because I know 2 goes into both of these, 10 and 4, so I get 5 over 2. Then I need to take a look and say, well, how am I going to go from 5 to 15? Well, I'm going to times 3. And 2 times 3 then would be 6. So I find that the cost of 15 cans would be $6. And what did I do? I divided by 2, then I multiplied by 3. So sometimes you may have to go back to smaller numbers to then be able to get to the larger numbers you're looking for. On the last example here, so Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So I need to be thinking what number goes into both 14 and 49. And I'm thinking 7, because I know 7 times 7 is 49 and 7 times 2 is 14. But I also need a number that goes into 8. And I know 2 will go into 8. So I'm going to end up with 7 and 4 for those two, or for the middle column. Then 7, and I said it was times 7 to get to 49. 4 times 7 is 28. So he would mow 28 lawns in 49 hours. And so I divide by 2, and then I multiply by 7. So use these examples to help you with your ratio tables, whether you have to scale back or scale forward, or just find a pattern that repeats itself over and over. Let me know if you have any questions.